Okay, we are moving on to section 5.5. How do you divide polynomials? Okay, so we want to divide these two polynomials here. And we do that using polynomial long division. So let's refresh our memories back to 4th or 5th grade when we learned long division. So let's say we want to divide 4 into this 74,567. Do we remember how to do that? We divide 4 into the first term. How many times does 4 go into 7? Once. Then we multiply. 4 times 1. We draw a line here. We subtract. 7 minus 4 is 3. We bring the 4 down. We divide 4 into 34. Goes in 8 times. 8 times 4 is 32. We draw a line. We subtract. We bring down the next number. Then we divide 4 into 25. That goes in 6. 6 times 4 is 24. Then we subtract. I should be putting my subtraction there. Okay, that's 1. And then what comes down next? The 6 comes down. 4 goes into 16 4 times. Times 4 is 16. That's 0. And then the 7 comes down finally. 4 goes into 7 1 time. And then I get 4 there. And that's 3. There's nothing left to bring down. So if you remember, 3 is called the remainder. Okay, so you could put, way back when, you put remainder 3, or you could write it as a fraction as 3 over 4, 3/4. So this would be the answer. So 4 goes into this number this many times. Okay, that's how we're going to divide polynomials using long division. We're going to put this as my, on the outside here. And we're going to divide it into this one. Now, one thing I did is I don't have an x squared term, so I'm going to put one in there, but I'm going to put a 0 as the coefficient. 0x squared. Okay, that's going to help when I subtract things and keep things organized. Okay, so what I'm looking at is that I'm looking at how many times does x squared goes into this first term. 2x to the 4th. The other way to think about it is, what do I have to multiply x squared by to get 2x to the 4th? And that would be 2x squared. Because 2x squared times x squared would be 2x to the 4th. So then I'm going to multiply this by everything here. I get 2x to the 4th. 2x squared times this is 4x cubed. And then this times this is be minus 2x squared. Then I'm going to draw my line. The key here is that I'm subtracting. So I like to make sure that I see that it's subtraction here, and everything I have to subtract. So this minus this goes away. X cubed minus 4x cubed would be a negative 3x cubed. Okay. Now this is why I put that 0x squared, because I'm going to have an x squared now. So minus a negative turns into a plus though. So I got 0x squared minus negative 2x squared is going to be a positive 2x squared. And then I can bring down the other two terms there, x minus 1. Okay, now I have to look at x squared. X squared goes into negative 3x cubed, negative 3x times. Because negative 3x times x squared is negative 3x cubed. Then negative 3x times 2 is a negative 6x squared. And then this times this is plus 3x. Draw my line, and I'm subtracting. Now, one thing, if you're not comfortable with remembering to subtract, what you can do is, what I like to do is change it to addition, and then change the sign on everything. Then I can just add. Sometimes that's easier. That goes away. You get an 8x squared. This is going to be a minus 2x minus 1. Okay, finally x squared goes into 8x squared 8 times. 8 times x squared is 8x squared. 8 times 2 is 16x. 8 times negative 1 is negative 8. Subtract. I'll change it to addition and change the sign. Okay, now I'm adding. So it's negative 18x plus 7. Now, once this degree is less than this degree, I can no longer divide x squared into x. So this is my remainder. So my solution to this whole thing, I can write it like this. 2x squared minus 3x plus 8 plus a remainder of negative 18x plus 7 over x squared plus 2x minus 1. That's my solution. Okay? So that's how I would do polynomial long division on that. Kind of a long process. Let's try one more. Okay? Now I'm just dividing a binomial into this term here with a cubed in it. Okay? So the x goes into x cubed, x squared times. Multiply, I get x cubed plus 2x squared. I'm going to subtract. So that's going to be this minus this is negative 3x squared. Bring the 4x minus 10 down. X goes into this. Negative 3x times, because negative 3x times this is negative 3x squared. This times this would be plus 6x. Draw my line. Subtraction. Subtraction. I'm going to change it to addition and change the signs. Okay, so that's going to be a negative 2x minus 10. X goes into negative 2x. Wait, I think did I do that right? Negative 3x times 2 would be negative 6x. Yep, made a mistake here, I think. Back up the bus here. So negative 3 times x is negative 3 negative 3x squared. Yeah, so this should be negative 3x squared, and this is negative 6x there. Yep. So I'm subtracting. When I change it to plus, I can change the signs. That's going to go away. This is going to be a 10x minus 10. Okay, and then x goes into 10x 10 times. Then I get 10x plus 20. Subtraction. Change it to addition. Change the signs. So when I add, this is going to give me negative 30. So my remainder is negative 30 over x plus 2. So this is my solution there. I should put a plus in between there. Okay. Now, so that's polynomial long division. Now, there's special cases when I'm dividing by, I'm just going to leave this a plus c. But it works for minus 2. When I'm dividing by a x plus something, I can use synthetic division, and it's going to make things a little bit easier for us. Okay, so let's do this one using synthetic division. So we've done synthetic substitution before. This is pretty similar. Okay, so I want to divide this into this. This is actually the same problem we just did. Okay, so what I'm going to do is same thing when I did synthetic substitution. I'm going to put my coefficients up here. So this is a 1, negative 1, a 4, and a negative 10. Now here's the key. The number I put out here is the number that makes this 0. Okay, so that would be negative 2, because negative 2 plus 2 is 0. Okay, so now I do the synthetic substitution like I did before. Multiply, I add, multiply, add, multiply, and I add, And now this looks very similar to what I got before. Both on here, compare. Let's get that. Okay, there. So you can see what I got here and what numbers I got here. This is my x squared term, my x term, my constant, and my remainder. So I get the same result. So this would be x squared minus 3x plus 10 with a remainder of negative 30 over x plus 2. Okay, but so synthetic division, much easier. Okay. Now synthetic division can also be useful if we know we have a certain factor. Okay. So let's just say I have this term here, and I know x plus 2 is a factor. Okay, when I divide these in here, if I get a remainder of 0 here, I know that this term is a factor. That's the way it works. So let's do synthetic division on this. So I'm going to put my 3, negative 4, negative 28, negative 16 out here. And now what makes this 0 would be negative 2, right? X plus 2 is a factor, so I want to divide x plus 2 in here, so I get negative 2. Okay, so I'm going to bring the 3 down, multiply, add, multiply, add, multiply, add. So this indicates that x plus 2 is a factor. So what that means is this term is also a factor. So remember, this is a cube term, so this is going to be a squared. So this is going to be a 3x squared minus 10x minus 8. And that's a factor, as is x plus 2. So if I'm trying to factor this completely, I've just factored it into a trinomial and a binomial. Okay, and then I can factor it further if this factors, and it does. This actually factors into x minus 4 and 3x plus 2. You can try factoring that on your own to verify that. Okay, so this would be factored completely, and it was done because we knew that x plus 2 was a factor, so when I divide that factor into this term, it results in an expression that's also a factor that I can factor further. It's a lot of factoring. Okay, we can also apply this to this next problem here. Find the zeros of a function. So I have this function, and x equals 3 is a 0 of the function. Find the other zeros. Okay, what is a 0? Well, a 0 is a solution if I set it equal to 0. It's also an x-intercept. Okay, so the key thing here is if x equals 3 is a 0, then x minus 3 is a factor, because if I substitute 3 in, 3 minus 3 is 0. Okay, so that is one of the factors. X minus 3 times something would factor this out. So I'm going to factor it using polynomial long division. Okay, so I get a cubed, a squared, an x, and a constant. So it's a 1, a negative 2, negative 23, and 60. X equals 3 is a solution. X minus 3 is a factor. So what number do I put out here? It's what makes this 0. It's the actual 0 that I put here. So it's 3. It's the actual number there. Okay. So make sure you get that right. So let's see. I drop that down. Multiply. I add. I multiply. I add, I multiply. Sure enough, this should end up being 0, because that would indicate that this is a factor. Okay, and the rest of it is, if this is a cube, this drops to a squared, so it's 1x squared plus 1x minus 20. So then I've got x minus 3, and then I can factor that further. This factors into plus 5 minus 4. So what are the other zeros? We knew x equals 3 was a 0, x equals negative 5 is a 0, and x equals negative or positive 4 is the other 0. Okay? So this graph, that would tell us something about this graph. That tells us that it's a cubic. So it's an odd degree with a positive coefficient. So we know that this graph actually has a shape like this. And we also know what the x-intercepts are. So this could help us in graphing as well. We know the x-intercepts are negative 5, 3, and 4. So we probably look something like this, negative 5, 3, and 4. It wouldn't look exactly like that, but you kind of get the idea of what it would look like on a graph. So that is it for section 5.5.